Hello. In this session, we speak about olive and how it turned to sustainable biofertilizers, chemicals, and physical characterization. Raw olive is fundamentally a clean, non-industrial byproduct devoid of synthetic heavy metal contaminants or persistent chemical toxins. This renders its raw elements baseline uniquely safe for large-scale systemic agriculture reintegration chemically. It exhibits unique properties that dictate its handling criteria. Carbon and polysaccharide matrix. Approximately 80 to 90% of the overall dry matter weight of the consists of structural cell wall. Polysaccharides. This complex framework include highly condensed cellulose core, complex hetero polysaccharide, um, glucuronide, and tightly bound plant pectin. This massive structural carbon reserve provides the core framework necessary to develop stable humic fraction within treated agricultural soil. Nutrient profile from a nutritional standpoint, the material stand out as an outstanding natural reservoir of elemental potassium. Um, it maintains modern, highly bioavailable configuration of nitrogen, phosphorus, magnesium, calcium, and key physiological micronutrient. The phytotoxicity were direct unmanaged application of raw dried olive almonds to agriculture topsoil result in palm to widespread agronomic crop failure. This phenomenon stem from three primary biochemical constraints: phenolic accumulation, the material contain intense concentration of total phenolic compounds and the complex low molecular with organic acid when liberated directly into the soil biosphere. This specific phenolic disrupt plant cell membrane permeability, embed root water potential dynamic, and trigger severe physiological germination arrest in seeds. Carbon to nitrogen imbalance through pomace feature and extremely wide skewed carbon to nitrogen ratio often expressed as when introduced directly into soil system indigenous hetero trophic microorganism mobilize rapidly to consume the abundant carbon matrix. To do so, they aggressively draw all available mineral nitrogen out of the surrounding soil matrix. This process results in temporary microbial nitrogen immobilization, starving growing crops of vital nutrients. Osmotic and the salinity vector rope most frequently exhibit a higher electrical conductivity rating. This elevates systemic soil osmotic pressure, limiting the plant's capacity to draw water and causing sodium and chloride ion toxicity inside young root architecture. The aerobic co-composing pathway to neutralize inherent phytotoxicity and build a highly effective organic biofertilizer. Raw must undergo managed aerobic co-composting because semi-solid pumice features a tight, dense structure and high moisture retention. It must be formulated with structural bulking against and external nitrogen impulse. Oligomas base animal manners structure bulking agent. The dynamic biochemical phase, the thermophilic phase, maturation and the humidification phase, agronomic performance and the soil benefits, foliar humides and mature olive pumice compost function as a high prior biofertilizer, enhancing long-term soil health across multiple physical and biological dimensions. Drought and climate resilience. The application of stabilized compost to improve aggregation soil stability. This enhances soil ultimate water holding capacity, enabling crops to maintain metabolic performance during extended drought by minimizing internal oxidative stress. Natural biostimulation and the systemic defense, the stable bioactive complex and the beneficial microbial population within the constant stimulate through development and trigger natural plant defense pathway against common soil-borne root pathogen. Active carbon sequestration shifting from synthetic chemical application to humidified organic pomace composite continuously increase overall soil organic matter percentage, creating available carbon sink while lowering the carbon emission footprint of the farming operation. Concluding framework, transitional labels from an industrial waste liability into a customized biofertilizer illustrate the practice potential of agricultural biofriendly system by addressing structural um, limitation through co-composing agricultural region can safeguard their local soil, optimize resource efficiency, and enable long-term climate resilience.